Alright students, so here are the solutions to the quiz that I've administered in class for you. Let us go through the solutions as usual. Do your corrections as you follow this video, and if you have made any mistakes, well, learn from them, right? So the first question, you are told to solve the following simultaneous equation, the following pair of simultaneous equation. So the first thing I'd like to do is to rearrange it in this way so that we have the x align, the x term align, the y term align, and I like the number on the other side, right? So it's very clear what I need to do after I arrange it in this way, because I can see straight away over here, right, that I'm supposed to actually use the elimination method because it's really quick and easy to do that, right? Yeah, how do I get rid of that? Erase that. Yeah. Okay, so what I'm going to do, right? So I'm going to first of all, okay, write it down, give it a name, call this equation 1 and the other one equation 2. Since we know that we are going to perform elimination method, we can see that we can just use equation 1 plus equation 2. What happened, right? 3x plus 5x give us 8x. 2y plus negative 2y, okay, they get eliminated. It's because it's equal to 0. Okay, and on the other side, negative 7 plus negative 1 give us negative 8. So from there, we have a situation here where we have x is equals to negative 1. Perfect, right? But we are not quite done. Okay, remember that you are supposed to also find the value of y. So substitute back into either one. In this case, equation 1. Why not, right? So 3 times x, which is negative 1 in this case, plus 2y equals to negative 7. Okay, you work this one out. We get a negative 3 plus 2y equals to negative 7. 2y is negative 4, y is negative 2, right? Finally, good habit, right? Always write out the solution properly as a final statement. X is equals to negative 1, y equals to negative 2. Okay, so that is the first question. Now the second question, just to make things more interesting, I introduce fractions, right? So I've mentioned many times before, there's nothing to be afraid of with fractions. The process is still the same. You know, it's just a very psychological thing, right? So you do it carefully and properly, you'll be fine. So the first thing I want to do is simplify, right? We don't want fractions forever. Okay, so when I look at the first equation, I have 1 third x minus 2 third y equals to negative 5. I realize that the denominator is 3, right? They are all 3's. So if I were to just multiply 3 to the entire equation, my denominator will nicely work out, right? So 1 third times 3 give me 1x over here. Negative 2 third times 3 give me negative 2 over here, and negative 5 times 3 gives negative 15. So I'm going to just do that, okay, and call this equation 1. Now, for the second equation, we have half x plus 1 third y minus half equals to 0, right? So in this case, when I examine the denominator, I realize the denominator are 2 and 3's. So I take the LCM of 2 and 3, which is 6. I'm going to multiply everything by 6. That will work, right? That will work in eliminating the denominator. So half times 6 give me 3, so I get 3x over here. 1 third times 6 give me 2, that's why I get 2y over here. And down here, half times 6 give me 3. And of course, I bring it over to the other side of the equation to make things a lot neater, right? So in this case, again, okay, we have this situation where we have negative 2y over here and positive 2y over here. Very neat, right? So it's a simple question really. Once we have that, we can eliminate the y very easily by adding them up. So equation 1 plus equation 2, we have x plus 3x give us 4x. Negative 2y plus positive 2y give us 0, so they get eliminated. Negative 15 plus 3 is negative 12, so this gives us x equals to negative 3 over here. Okay. Finally, we need to find y, so substitute negative 3 x equals negative 3 back into equation 1 or equation 2. Okay, so we have x minus 2y over here equals to negative 15. That works out to negative 2y equals to negative 12, y equals to 6. Okay, so finally, write down the final solution. X is equals to negative 3 and y is equals to 6. So I hope you are doing well so far, right? Okay, the next question that I gave you is this one, right? I'd like you to explain why the simultaneous equation of this pair of simultaneous equation. Oops. Um, yeah. Okay. Maybe I should just use highlighter. Right, just use a highlighter. This one, okay, these two equation has no solution. Okay, so if you have understood the idea of simultaneous equation, and you actually can visualize them on the Cartesian graph, will realize that a pair of simultaneous equation will have no solution if they are parallel, right? So how do we test whether this pair of simultaneous equations are parallel? Recall, okay, back in the when you were learning about equations of straight line, if the gradient, okay, is actually the same and they have different y-intercepts, okay, that means they are parallel. We have learned that before in the previous lesson, right? So y equals to mx plus c is the general form. M represent the gradient, c represent the y-intercept, right? So we take the first one, 6x minus 3y equals to 4. We are going to rearrange them until we get the general form y equals to mx plus c. So by rearranging it, we get y equals to 2x minus 4 over 3. So that means the 2 over here, this is my gradient, right? And this, let me use a different color, right? This is my y-intercept, okay? So the second equation is already in this form, y equals to 2x plus 5. You can see that the gradient is the same and the y-intercept is different, right? So this tells us that these two equations, they are actually parallel, right? So explain it logically. Okay, so you can say that since equation 1 and equation 2, because I've named them as such, have the same gradient but different y-intercept, they are parallel. Okay, so we have successfully demonstrated that they are parallel by making use of the properties of the general form of a straight line, right? A linear line, okay, y equals mx plus c. After we establish that fact that they are parallel, we can go on and say, since parallel lines do not intersect, okay, we know that in order to have solution for a pair of simultaneous equation, they have to intersect. Since they do not intersect, there's no solution. And that is how we can explain, okay, this entire question in a very logical manner. All right. So I hope you have done well. If you have not, don't worry. Just learn from your mistakes. All right. Have a nice day.